Okay, good morning once again, everyone. And there are only 24 participants. So let us wait for 5 minutes, okay? Till then, can anybody tell me what we have done in the last class? Till how much we have completed in the last class? Components. Okay, thank you, Lancy. Yes, Tashi, meeting is locked. No, if they come, I'm admitting. If I admit, they can enter. At present, I'm not seeing anybody, okay? So nobody is there. If the meeting is locked, I have to allow them to enter. And I am allowing that. Manhaka is waiting. Here it is not showing. Manhaka, I'm not seeing, okay? Others, I am allowing to enter. Those who are coming. Maybe she has some network problem. Just ask her to disconnect and then connect once again.
Mm.
Tashi, if you're saying something, I can't hear you. You can write it in the chat box. 38 participants. Should I wait or should I start? Start. Okay, let's start then. So today we will be discussing about the other topic that is engineering properties of soft, weak and compressible deposit. Okay, guys are still coming. So now I'm going to share my screen and I will be not able to give admit to those coming now. Okay, we have already waited for long. Is my screen visible? Can you see the screen?
Mhm.
Okay.
Yes, ma'am.
Okay. So, engineering properties of soft, weak, and compressible deposit. So, what do we mean? What do you understand when we say this kind of soil that is soft, weak, and compressible? See, it's written certain types of ground contains layers of very soft materials like peat and clays. So some grounds they are very soft. They are not suitable for construction works. Okay. So generally the ground containing peat and soil clays are of those type. They are soft. They are not suitable for construction purposes. Okay. What is peat? Anyone? What is peat? Clays. All of you know peat. Anyone can unmute yourself and respond, or you can write in the chat box. Anyone, what is peat? No response. Are you guys there? Are you? No, ma'am. Anybody else? Yes, Roganlu soil it is, but what kind of soil? The type of deposit from a decompose. Yes, exactly. Tashi. Good. So, it is a kind of soil which is formed by the decomposition or decay of some of these vegetable matters, or we can say organic matters. Okay, it is very soft. It is not at all suitable for construction purpose. Then these layers are likely to compress if they are loaded by overlying structure or if the groundwater level changes around them. Of course, if the soil is soft, then it will get compressed when loads are applied. Okay, that is what it is said here. And if the ground level changes, then also it will get compressed. That is what. And it will not become not be suitable at all. The only thing is that for construction purpose. And this compression may result in depressions appearing in the ground surface or under structures, potentially damaging foundations and services. Obviously, if we do construction on those type of soil which is soft and compressible, what will happen? There will be depressions. The foundations will get damaged. The structure will get depressed and settled. And if the settlement is settlement that occurs, it is differential settlement, then the loss will be to a huge amount. Okay. Then why does it occur? Many ground materials contain water-filled pores. Okay, the pores, the voids between the soil particles, or the pores, we can say, these are filled with water, and as a result they become soft. Okay, then peat, alluvium, laminated clays, are some silt and sand are the types of deposit commonly associated with various degrees of compressibility. So these are the types of some types of soil, we can say, which are soft and compressible. Okay. Then we see here the various principles of treatment. How can we treat those types of deposit which are soft and compressible? There are various methods which are available. So few of them we are seeing here. That is, first is vibratory surface compaction and deep vibro compaction. Then removal and replacement of soft cohesive deposit of limited thickness. Preloading of existing soil or loose fill. Preloading with vertical drains. Already before I have told you, preloading we can use along with vertical drains also. So that is what. Okay, we'll see one by one all of them. Then dynamic replacement. Stone column, piled embankments in areas having soft soil to large depth. Viaducts for high embankments on ground having very deep soft soil with organic deposit. So let us see one by one. First is vibratory surface and deep vibro compaction. So here the surface vibratory compaction is used for densification of loose cohesionless soil using vibratory roller. So here a vibratory roller is used, and with the help of, or we can say with the application of vibration, the loose deposition, loose cohesionless soil are compacted. Okay. Then deep vibro compaction can be used for loose sandy deposit having less than 15% of fines for depths up to 10 meters. So deep vibro compaction is used for when the depth is up to 10 meter. Okay, and we should have 15 less than 15% fines. Then compaction is carried out by inserting the probe up to the design depth of improvement and allowing the soil around the probe to get compacted for certain time interval. Then the probe is raised by about zero point 0.5 meter to compact the soil around the vibrator, and the process is repeated. So in case of this probe, it is used in case of deep vibro compaction. Okay, not in case of surface. In case of surface vibratory compaction, we use roller, and in that type of roller, this vibration vibratory system is provided in those that kind of roller, and vibration is applied to the soil. And in case of deep vibrocompaction, a probe is fitted. What is a probe? Any idea? Anybody? Any idea what is a probe in case of deep vibrocompaction? Yes, no, anything? No. Okay, a probe. It is a rod-like structure. You can say. Okay, I don't have the image. Otherwise, it would be clear, more clear. I mean, anyways, you try to understand. Probe. It is a rod-like structure, and it is inserted inside the ground, and then vibration is applied inside the ground so that the soil gets compacted. Okay, and this process of inserting the probe is used for deep vibrocompaction. So the probe is inserted up to design depth. The depth is designed means depending on the total depth, the up to how much depth you need you need to compact the soil. And so depending on that, the probe depth is designed. Okay, and this process is repeated. Uh, After every step, the process is repeated to achieve the required amount of compaction in the soil. Is it clear till this much?
Yes, ma'am.
Okay. Next is removal and replacement. So this process, removal and replacement, you see what it is, for localized areas with soft soil of limited depth and thickness, removal of unsuitable material and replacement with suitable fill may be carried out. So this is the process already I have discussed in last class, where we discussed various techniques of ground improvement. So what is done? The soil which is soft and compressible, it is removed from the site, and then that place where you have removed, from where we have removed the soil, that place is filled with some good quality compacted soil. Okay, the bad one is, that is the soft one, is removed, and it is filled with, replaced with a good quality compacted soil which is suitable for carrying the construction works. But this process we cannot apply in every situation. For localized areas, and also for the places where the depth of the soil, depth of this loose soil is less. If the depth of loose soil is less, only then we can apply this process. Otherwise it will not be much economic, and also it will be a hectic one. And also the area of the site should not be much more. The area is also small, and the depth of loose deposit is also small. Then only we can apply this process of removal and replacement. Then see, the removal and replacement may be required to be carried out even in cutting areas where the naturally occurring soil were found to be of a low shear strength and high moisture content. This is what this kind of soil only we will replace, which has low shear strength and high moisture content. If there is high moisture content, then it will be a compressible one, so we need to remove this type of soil. So this is one of the process, removal and replacement. Next is Preloading is already discussed. Can anybody say what is preloading? Just an idea. I don't want a perfect definition. Just what is preloading? No response. What happened? Preloading. What is preloading? Anyone? You can either unmute yourself or you can mention it in the chat box. Giving additional vertical stress. Anybody else? Before load. Before load means, Tashika, can you elaborate? Load is applied to soil for consolidation. Okay? Providing stress so that settlement is reached pre consolidation. Okay. Okay. So it is application, internal application stress to certain mechanical system. Okay. Good. So in simple language, we can just say it is the preloading means the application of some load from external source before starting any construction work. Okay, we apply the load in the soil, and before the construction work is started, that load is kept for certain period depending on the uh, amount of compaction or consolidation required, and after which the external load is removed. Okay, I hope you have understood. It is clear. In very simple language, I'm just saying, not using any engineering terms and all. So after achieving the required amount of consolidation, the load is removed from that place, and then the construction work is started. Okay, so for low embankment over soft compressible soil where the poor ground is of limited thickness or is capable of compressing rapidly under load of excess preload fill due to presence of sand lenses, preloading may be resorted. So that is what the load is applied and then it is removed. That is what it is said. Okay, nothing much. And here also this thing limited thickness, here also the thickness of the soil is limited. Then only if the thickness of the soil is limited or less, then only we can apply this preloading technique. Okay, and if we see that the thickness is much more and the time that is given to you is also very less, then what and we are in such position that we can apply preloading, we need to apply preloading, then what we can do is we can combine vertical drain along with preloading. Okay, for combination of the process of vertical drain and preloading is a process where the this compaction degree of compaction is achieved much faster. Okay, So next is prefabricated vertical drains and preloading. That is what we have seen. I have told just now that with increased thickness of the soft clay, where the consolidation period is too long for full consolidation of primary settlement, vertical drainage may be incorporated in conjunction with preloading in order to accelerate the settlement. Just now I have told you, right? If the thickness is more, then the period of consolidation is long, consolidation process is of longer period, and you have less time in your hand to complete the work. In that process, in that situation, we can apply prefabricated vertical drains and preloading together in conjunction, means in together we can apply in order to accelerate the process of settlement. Okay. Next is dynamic replacement. Dynamic replacement also I have told you, I guess. Just in simple, can you say what is dynamic replacement? What it is? What is dynamic replacement or dynamic compaction, we can say? Replacement of loose of low good compacted soil. It is not replacement. Giving external stress by using heavy mass. Yes, exactly. So dynamic compaction, it is the process of compacting the soil or densifying also, you can say, by the application of heavy load. Okay. So dynamic replacement may be used for densification of loose cohesionless soil which are up to 5 to 6 meter deep and where height of embankment is more than 2.5 meter. Then this dynamic replacement method we can use if the cohesion soil is loose cohesionless and it is up to 5 to 6 meter deep only. The dynamic replacement utilizes heavy pounder usually lifted by crane to designed height and then dropped onto the soil in a grid pattern such that the site is adequately covered. So this load, the heavy load which we put into the ground, it is done in grid pattern. I think grid pattern you all of you know, and even if you have some confusion, we will study this in details in the unit of dynamic compaction. Okay. Then due to large vibration induced by dropping of the pounder means that load or heavy load. Okay, this method is only suitable at locations away from settlement sensitive structures. So this a heavy load is lifted with the help of crane and then it is put in the ground. It is dropped in the ground. Okay. So in this case, what will happen? There will be a huge amount of vibrations will be created. Okay, and due to these vibrations, the adjacent structures, the structures which are already constructed in the nearby areas, will have to suffer from certain kinds of problems, like cracks and all may also appear if it is to a much extent. So generally this process of dynamic compaction or dynamic replacement is used where the site is away from any structures, there is no structures nearby, and if it is there, it should be in a at a far distance. Okay. Then stone columns may be provided in areas where subsoil consists of more than about 5-meter thick soft cohesive soil, and where stability and stringent considerations cannot be satisfied with conventional removal and replacement of soft material. So, if the depth of the soft deposit is very to a great extent, if the depth is more than about 5 meter, so in that case we cannot use removal replacement method, and also the dynamic compaction method is also not suitable, because we cannot compact the soil to such depth which is more than 5 meter. In that case, what is done, some kind of stone columns are constructed, some columns, and these columns are constructed inside the ground surface, which are generally made of stone, that is gravels, you can say. Okay. So it is compacted and it is inserted inside the ground, which provides strength to the soil. Okay. And about stone column also we will study in details in our next modules. It is there if you see the syllabus. Then we come to piled embankments and viaducts. So, in soft soil areas, embankment height exceeding the pre consolidation pressure will give rise to excessive settlement. This can be avoided by means of structural solutions such as viaduct or piled embankment. So, what is viaduct? Anybody can say what is viaduct? Anyone, what is viaduct? No response for viaduct.